What if time, the ticking clock, the turning calendar, is just an illusion? We experience time as a river, but the universe doesn't seem to care about our perception. The laws of physics suggest reality is far stranger than our daily experience. Is time a true dimension, or just a story we tell ourselves to make sense of change? We measure life in seconds and years, but the arrow of time might only exist in our local corner of the cosmos. The universe's fundamental equations work just as well backward as forward. Our sense of time's direction comes from entropy, the universe's tendency toward disorder. Maybe time is just the universe getting messier. Is time a building block of reality, or an emergent property, like wetness from water molecules? This question pushes us to the edge of human knowledge, challenging our basic assumptions. The cosmos isn't required to make sense to us. Its version of time may be far stranger than we can imagine. Enter Albert Einstein, who shattered our old ideas about time. Newton saw time as a universal clock, ticking the same for everyone. Einstein showed it's not absolute. It's flexible, stretching and squeezing with speed and gravity. Imagine two atomic clocks. One stays on Earth, the other rides a fast rocket. When reunited, the rocket's clock is behind. Time passed slower for it. This is time dilation. Astronauts age a bit slower than us. There's no single universal now. Your now and my now can differ. Gravity warps space-time, slowing time near massive objects. Clocks on skyscrapers tick faster than those on the ground. GPS satellites must adjust for these effects, or your directions would be wildly off. Time is local. Every object, person and planet experiences its own flow. There's no master clock. The universe is a patchwork of countless time streams. An alien near a black hole would experience time much slower than us. Our billions of years could be moments for them. Einstein revealed time as a flexible, personal dimension, not a rigid ruler. The universe is a mosaic of different timelines, all ticking at their own rates. Time is not a constant, it's a deeply personal experience. Some physicists go further, proposing the block universe theory, eternalism. In this view, time doesn't flow. Every moment, from the Big Bang to the end, exists simultaneously. The past, present, and future are all equally real, laid out in a four-dimensional block. Our sense of moving through time is just an illusion of consciousness. Think of reading a book. All pages exist at once, but you experience them one at a time. Einstein's relativity supports this. There's no universal present. What's now for you could be past or future for someone else. The distinction between past, present, and future may be a quirk of human perception, not physics. The universe simply is, a static sculpture of space-time. This idea challenges free will. If the future is already written, are our choices real? Not all physicists agree, but it's a logical extension of our best theories. The river of time may be a frozen landscape, not a flowing stream. Let's explore the twin paradox. A classic thought experiment. Imagine twins, Stella, the astronaut, and Tara, who stays on Earth. Stella travels near light speed to a distant star and back. For Tara, 40 years pass. For Stella, only 10. Stella returns 30 years younger than her twin. She's traveled into Earth's future. This isn't science fiction, it's a real consequence of time dilation. From Stella's perspective, Tara was moving, but acceleration breaks the symmetry. Stella ages less. Forward time travel is possible, built into the laws of physics. Every time you move, you travel into the future, just by a tiny amount. The twin paradox shows there's no single objective timeline. Time depends on your path through space-time. Different journeys mean different experiences of time. Traveling to the future is possible, but what about the past? The grandfather paradox asks, if you go back and prevent your grandparents from meeting, how could you exist to do it? This logical loop suggests backward time travel may be impossible. Some physicists think the universe has a chronology protection mechanism. Backward time travel would require infinite energy or create a black hole. Others propose quantum solutions like the many worlds interpretation. Changing the past creates a new timeline, not altering your own, or the Novikov self-consistency principle. You can visit the past, but you can't change it in a way that creates a paradox. If you tried to stop your grandfather, you'd fail. Your actions would become part of history. The past may be fixed, with time travelers simply playing their roles. Backward time travel remains a mystery, tangled in paradoxes and speculation. The universe may allow only one-way trips. Forward. The rules of time are still one of physics' greatest puzzles. We've journeyed from Einstein's stretchy time to the mind-bending block universe. Traveling to the future is real. Traveling to the past is tangled in paradoxes. Our intuitive sense of time is just the tip of a cosmic iceberg. Physicists are still searching for a theory that unites gravity and quantum mechanics. Maybe time isn't fundamental at all. At the smallest scales, time and space may dissolve into quantum foam, where cause and effect break down. Every new discovery adds a piece to the puzzle. The quest to understand time drives science forward. The final chapter is yet to be written. Keep looking up.